All right.
All right. Welcome to our weekly weather discussion on the 5th of February. This is about the coldest day of the year. It's not quite, but it's close to it climatologically, at least as far as the entire northern hemisphere goes at -5 at 8:50. It's really close to that. I'm going to start this animation. Pete and Tom Whitaker put their heads together to make a week-long satellite imagery at 30-minute increments, I think, for the last 7 days. So you can watch this animate a couple of times. One thing I want to keep control of the stop, so when we get to the beginning again, we can start again. There are two major features this week and a couple of minor ones that are worthy of a little bit of attention here at the beginning. Last week, you'll remember we were talking about a trough feature that developed underneath the cold pool at 500 millibars. I'll stop it for just a second. And both Michael and I had something to say about it. I said something about the current structure, and Michael looked at it into the forecast and watched this little spin up that comes. This is Friday afternoon last week. Watch this little spin up that comes out of the Gulf of Maine when I start this again. Look at that beautiful little cyclonic disturbance that gets organized in the cold air. This is underneath, -34, -35 air at 500 millibars. Absolutely beautiful little vortex. And there it goes racing away into the graveyard of the North Atlantic. So that's item number one that was kind of interesting.
Hey, John.
John,
I just want to let you know, you can, when you're stopped, you can actually grab a hold of that dot and slide through the loop yourself.
Okay.
If you stop it, grab a hold of that dot with the click, and you can adjust where you are in the loop and go pan back and forth or whatever. So
all right. Okay.
you want to highlight a certain region.
Okay.
Right. Also, John, I'm wondering if that would classify as a polar low.
It strikes me that it has so many of the characteristics, except the ice edge characteristic, that are common to the polar low environment. Although in this case, it has the Gulf Stream edge, which might behave the same way thermodynamically. It's just
Right.
there's not
Strong low-level baroclinicity.
Yeah, there's a huge difference in emissivity across the Gulf Stream front, and there's a huge difference in sensible heat flux off the ocean there too. So yeah, it's really a beautiful little storm. It'd be great to see if this. I don't know if it was modeled accurately as a cyclone. Yeah. Was it?
Yeah.
You know
So in some of the earlier forecasts, that's what sort of caught my eye. I kept seeing this inverted trough, and then the North American model, the NAM, began to roll it up into a cyclone at least a few runs before Friday. I think on Friday morning run last week, it didn't show up as a cyclone in the NAM or the GFS, but earlier runs had it. But I think that's probably a modelable feature.
Yeah, an absolutely beautiful little storm. It'd be great to take a look at that, and especially to see it emerge from this trough feature, which is right there in the Gulf of Maine. And then here you go under the cold air, and it just spins right up into this beautiful little cyclone. And little is the right word. It's a small scale feature, as you know. So that was Friday into Saturday. And you can see as that's taking on shape, here come the clouds for our Saturday evening, Sunday snow event, which gave us, about 4 inches of powder. Look at that beautiful cyclone in the central part of the United States. We're on the cloud head side of this, on the northeast side of it. It was a little bit south of us. I think snow totals were even greater to the south, but we ended up with something just shy of 5 officially, but a lot of us had 6 or so, maybe even more in the local region. And Grant Petty and I used to play a concert in Dickeyville, Wisconsin, which is right on the border, right where the cursor is in Iowa, almost every year on the last Saturday in January. And I wrote to Grant last week, I said, good thing we're not down there this week. We'd be again in a snowstorm. 4 out of the 5 times we did that event, we drove home in a snowstorm. So this would have been another one to add to that. Just incredibly persistent that this date, this last Saturday in January, is at least in the last half decade, has been snowy. It's just amazing. So that was our Saturday, Sunday event. And look at that, was a beautiful looking storm. And that was the one that evolved. I'm going to let this go a little bit on its own. I'll just stop it here and say, this is, the early morning on Sunday, 12Z, and this thing is really starting to look a little bit discombobulated. The main cyclonic rotation center is back here, maybe just to the east of the southern tip of Lake Michigan. And then something's getting reorganized. This was, again, Michael, we were talking about the secondary development. There was a secondary tendency for secondary development along the Delmarva Peninsula, middle Atlantic states. But from the satellite perspective, it doesn't present itself as a very well-organized disturbance. And I think that continues as we go into the day on Sunday. This thing looks like 2 separate pieces. This is the lingering disturbance that we got our snow from on Saturday, Sunday. And this is the beginning of something, I guess, off the coast, but it doesn't look like it's got much potency. I have friends just west of Reading, Pennsylvania. It was snowing on Sunday afternoon. So they started having snow from this event on Sunday, and it lasted all the way to Tuesday morning. And in some places in like, where is this? Where was the high clouds? Maybe right here in Northwest New Jersey. This is on Monday about midday. Northwest New Jersey, there were places, I think McMillanville, New Jersey had 35.1 inches of snow or something like that. Quite a number of places around, well, not Reading itself and north of Philly, but up towards Allentown had 25 or so inches of snow. So this was a major snow event in eastern and northeastern Pennsylvania and northern New Jersey. But boy, if you look at the satellite picture and somebody were to ask you, pick out from satellite imagery the 6 biggest snowfalls of the last 10 years or something, you'd never pick this one. You'd absolutely never pick it, I don't think. I wouldn't, because it just doesn't look like it's that well put together. And I'll keep on animating this. And that continues to be the case. It snowed all the way through. Now we're on to Tuesday. It snowed all the way into Tuesday in some of those locations. And this is early Wednesday, sorry. But all the way into Tuesday. And by the time that was all over, this disturbance had really become well organized, and it's a massive feature off the east coast of the United States. But that was a major snow event, probably the biggest snow event in many of those locations in probably the last 10, 15, even 20 years in some places. So a pretty incredible event. And then the last one, of course, at the end of this movie is going to be getting all the way to the end here, which is just last night. And that is, here's the beginnings of the Thursday event for us. This is now Wednesday afternoon. It's not well put together over the high plains, and it's in the Intermountain West. It doesn't get much better put together as we move into Thursday. And it started out warm and rainy, 37 degrees and raining at 6 a.m. on Thursday morning, and then a quick changeover. But look at that. That doesn't look like a very well-organized event, and yet we got a pretty decent snow out of it. So the whole week has been characterized by storms that don't present themselves that well on the satellite, but that end up doing some substantial weather production. And here in the last bit of it, I just stepped through these. Now you can start to see this storm, and the cold frontal cloudiness associated with it is a little bit more impressive. About 2/3, the southern 2/3 of this was rain this morning, and then the northern 2/3 over western New York State, and again over the heavily hit areas from the early week in Pennsylvania, where it was snowing again. And then snow moved into New England. So this is all snow in New England this morning, although not very much. And today is the 43rd anniversary of the beginning of the blizzard of '78, which was a seminal event for me. I wouldn't even be doing this weather discussion right now if that had not happened. Who knows what I'd be doing, but it wouldn't be this. And so there it goes off the coast just at the last hour or so. So all the cloudiness and precipitation is out. And the next weather feature that we have to worry about, besides the cold, and even the cold shows up in the infrared. Look at how cloudless and dull gray white this air is over the central and high latitude provinces of Canada. That means it's almost as cold as space. And it's really cold. And then this is a weather system that's going to slide on the southern edge of this punch of cold air that you can almost already see in the infrared. And that will give us a chance for snow on Saturday, Sunday, probably even Monday too, but not much, just flurrying here and there. So that's the recap of the week over these last, several snow events. And in fact, the last one from last night or yesterday finally put us over the annual climatological average. And you can see that right here. So here we are at about February 3rd or 4th, and that's we're finally we're at 36 inches for the season. I never have much faith that that's the case, except that the snowbanks that we have around town and the snow in my driveway is of a stature I haven't seen in many, many years, I must say. So it's been an incredible period of heavy snow or continuous snow from mid-January until now. And here's the climatological rate of increase of the snow depth in blue. And then here's the local period over the last 3 weeks or so, since just after the insurrection in Washington up till now. And that's, that slope is considerably larger, and that accounts for the deep snow depth. We haven't had a snow depth of 10 inches or more in Madison in many years. I think it's been more than 10 years since that's happened. And then snowbanks all around town are testifying to the same thing. So we've had a period of relentless accumulating snow, and we finally pushed over the climatological average for the date for the first time today. Okay, so let's take a look at what the current weather looks like across the country. What happened? Oh, I know what happened. This isn't what I want to show. I want to go down here. I've got a surface map that I steal from the Weather Channel every day for my 101 class. And it does the job of giving a brief overview of what's happening around the country in a nice way, because it has isobars on it. Of course, in the Intermountain West, they go crazy with their algorithm for highs and lows. One doesn't pay any attention to this, but one can pay strict attention to this cyclone that's in southern Ontario, southeast Ontario. This is our storm from yesterday, and it was an intense event. And it's got this band of precipitation, most of it rain, actually up to the Cape Cod and the islands and offshore of Maine, and then snow in northern New England and just south of James Bay. And then some lake effect snow we'll highlight in just a minute over the state of Michigan in relatively strong winds, which one can't see from this map, are also characterized by substantial cold advection. So I'll take this, and then off the coast, a big anticyclone off the coast of the Pacific Northwest. And this is a change from the last couple of weeks. Last week especially was a very active period. As you might recall, lots of news stories about the atmospheric river and all that stuff in Southern California. And then there was a second weaker one that we noted in last Friday's discussion that dropped snow in the Cascades of Washington and Oregon. And now no unsettled weather at all along the West Coast. And that's a respite for all of them from rain and snow. And that may last for some period of time. And that, of course, has ramifications for the jet structure, or maybe the jet structure had ramifications for the anticyclone. It's a chicken and egg problem, of course. But there's a change in the weather in the Eastern Pacific Ocean basin in the Northern Hemisphere this week. Okay, and then let's look at, I'll get rid of this, and let's look at the temperatures around the country too in a quick glance. And really, it's chilly in a lot of places, but it's not particularly cold down over Florida. This is from 10:30 a.m. Eastern time, 73 in Miami, 65 in Tampa, 56 in Jacksonville. It's not so bad, 57 in both of the coastal big cities or important cities along the East Coast of the Carolinas, Cape Hatteras and Charleston. And it's a little chillier if you go to the higher latitude parts of Georgia, 46 degrees, but it's really frigid only over the high plains. Mandan Nation here in the Sioux Nation. This is where people for centuries had to deal with this kind of weather over and over and over without indoor heating, except for fires. I don't know how they did it, but it's too bad we lost that culture and stories from that culture, because there must have been unbelievable stories of the harshness of winter in the high plains of central North America. It's a real shame that those things are gone. It's chilly in much of New England, but not cold for February 5th, and the same in the Pacific Northwest. Occasional elevated stations reporting at 29, but generally a pretty nice day across much of the country. It's really not unusually cold. It will become so over much of the country as we move into the coming week and the weekend. For us, it'll be immediate for us, less so for other parts of the country. So I wanted to show you next the radar summary, and you can see the precipitation now moving off the the coast of New England into the Gulf of Maine, and it's moving along the coast of the Carolinas, but it'll eventually get across and off the coast as well in those locations. And then some heavier, more interesting banded structure to the precipitation over eastern Texas and parts of southern Louisiana. That involves even in this short 3 or 4 hour movie. So that's kind of interesting. I don't really have any more to say about that, although there's plenty more to wonder about with regard to that. We'll get to the lake effect snow in a minute. It's concentrated in the immediate lee of Lake Michigan by virtue of the fact that we've got a cyclonic circulation up and around this region of the Ontario-Quebec border. And so the flow is coming around from the south-southwest or west-southwest across the lake. And then this area of not so well organized precipitation, I think that probably more reflects interruption by the mountains in Idaho and parts of Montana. This is the next potential weather disturbance for us, and we'll try and find evidence for that at the upper level maps in just a minute. Okay. So I wanted to go to the lake effect area near Michigan. This is a visible satellite image from the last several hours, maybe up to about 10 o'clock. And here's Lake Michigan itself, so you can watch that. And you can't really see any particular structure because there's snow on the ground underlying the clouds that are streaming above the ground. But you get a sense that there's little individual streams of clouds that get themselves nicely organized as they come off the lake. And of course, there's surface divergence at the boundary of the lake when the winds are coming off the land somewhat more slowly and then stronger across the lake, given the pressure gradient force that produces surface divergence in the cloud-free region. But it eventually catches up, and there's stratocumulus and surface convergence begins again along the coast, and there's some lake effect snow there. And you can see the fresh snow over northern Illinois, parts of Iowa, nicely illustrated here as well. If we look at, there wasn't any Michigan-centric radar, so I picked just the northeast radar, which is a little bit more of a close-up of Michigan itself. But you can see these little tendrils of snow, and we'll see in a surface map in a minute. In fact, there's heavy snow in Midland, Michigan this morning for a period of time. And that's just to the southwest of Saginaw Bay there. And so heavy snow there, and most other places light snow, but it's intermittent and extremely local, as is the case with lake effect snow most often, as probably many of you know. And so here's the map that indicates where it was snowing in Michigan. So light snow and no snow in Detroit, light snow in Ann Arbor, light snow in a lot of places in the western part of the state. And then there's the heavy snow at Midland, 20 over 18. And it's all fetch off of the relatively skinny Lake Michigan. This fetch is not the best fetch for heavy snow, but something interesting is going on there. Could be connected perhaps to the western side of the main cyclone, which is centered up in this region to the northeast of Lake Superior. We were at the time 8 degrees with a dew point of -0. So that makes it even more menacing than just 0. And then the temperatures off to the north and west are below 0 in many locations, but not uniformly and not entirely. And so you've got a few, like in North Dakota, -2, and then a few that are just above 0. That's our fate for tomorrow and Sunday, is what it looks like to me. Okay, and then finally we get to the West Coast satellite image. That's a lot of talking about stuff that's going on over the continent, but here's the West Coast satellite image. And here's the state of Hawaii, where I'm tracing it with the cursor. So in case you can't see the brown against the gray, that's rather hard to see sometimes. And so we've got a stationary cyclone kind of sitting right here to the northwest of Hawaii. I guess Midway Island is out there somewhere too. And then one of the cloud streets clearly has its feet in the tropics, because the southern part of the big island is nearly in the cosmological tropics. I think it's at 24.5 degrees or something, but it's just about in the tropics. And that stream of water vapor and cloudiness that results from it makes its way all the way deep into the mid latitudes. And then this feature here is on the northeast side of this upper level disturbance. There's a weak upper level low sitting well off the coast of California too, that seems obvious. And that's reflected in the cumulus clouds that are kind of tightly packed and obviously rotating counterclockwise around some circulation center. And well to the west, at about, well, past the date line, so into the eastern hemisphere, there's a pretty big storm at about the latitude of the southern Bering Sea. And that's an impressive event, as it turns out, strongly forced vertical motions in that location. You can see even obliquely here, pretty cold air at upper level. So you got everything you need. You can't see all of those ingredients, but I can testify to the fact that strong QG omega forcing is producing this cloud head in the western Bering Sea, and then cold air aloft suggests that the development is aided by weak stratification generally in the vicinity. And so that all those things tend to be true out for that event, as it turns out. Okay, now I got to try another trick, and that trick is I got to go to my second screen. Here it is. I don't know why I have 2 screens, but anyway, I do. The last thing I want to say is I want to draw your attention to a really interesting event that's going on just off the coast of Northwest Africa and south of the Iberian Peninsula. And that's down here over Western Sahara, Morocco, and then parts of Mauritania, Northwest Mali, and especially Algeria, which is the biggest country in Africa. You realize that? I didn't realize that until I was looking around. It's the largest country in Africa in terms of area. And most of it's the Sahara Desert. But Algeria is an interesting country because the coast of Algeria is the southern Mediterranean climate. It's moist. You know, they get a decent Mediterranean climate in this thin little strip that's right on the coast of the Mediterranean, not very far inland. You're into the northern fringe of sort of the semi-arid entranceway to the Sahara Desert. Most of the rest of the country is the Sahara Desert. And look at this surface map. This is sea level isobars are in black, and then 1,000 to 500 millibar thicknesses are dashed red if they're greater than 5460 decameters, and blue if they're colder than that. But you got a deep upper level troughs suggested by the thickness field over much of western Algeria, which is the Sahara Desert. And there's a cyclone right centered just about over the Rock of Gibraltar. And so a cold front going right, clearly through the western part of the Sahara Desert and northern Mali and Mauritania. These are places that don't get a lot of rain at any time of the year, and it's not a very rainy time of year now. And in fact, a couple of cities in the southern part of Algeria, one is named, how do you say this? Tamarasset, I think, is almost on the southern part of Algeria. They get one rain day per February climatologically, and they get about 0.3 inches of rain for the whole month. So maybe that's what it comes. They get one shower in the month of February on climatological average, and that's far southwestern Algeria. So it must be features like this, and they must be relatively infrequent, that bring any precipitation into the western part of the Sahara Desert. And I think I've read, I didn't read about it in this particular instance because this is a feature, and I'll talk a couple of minutes more about what's going on with this feature in the northwest part of Africa. But I think rains at this time of year can promote the production of locust swarms in parts of the vegetated, more western coasts of these countries. And that's really bad news for agriculture, because these locusts can do extraordinary damage to places that are already on the edge in terms of their agricultural production because of their proximity to the Sahara Desert. So if you moisten these places a little bit too much, and you actually moisten the Western Sahara, that is not good news for agriculture in that region, surprisingly. So I want to show you another map that I had here for this same time. This is 12Z this morning, so it's a 0-hour forecast from the GFS. So if you're guessing that this depression in the thickness field is unusual, you are correct. This is the 500 millibar geopotential height and the anomalies that are associated with it. This is from a prior forecast, so it's a 6-hour forecast, but it's valid at the same time. And so we're talking about anomalies that are in the 3 to 4 standard deviation range, just off over the Cape Verde Islands and off of Western Sahara and parts of Northwest Africa. So this trough is exceptionally deep and very unusual for this location at this time. And so downstream of it, this is still borderline mid-latitudes. It's still about 28 degrees north or something like that. And surprisingly, the quasi-geostrophic omega equation still works really well with Rossby numbers that are characteristic of 28 degrees north. That's one of the great things about the QG theory, is it's more flexible than its rigorous definitions might suggest. And Peter Knippich and I, about 15 years ago, did some work on heavy precipitation in Northwest Africa in the wintertime. And we found that it was a great way to diagnose the forcing for the precipitation that in that case struck Morocco in fairly flooding sort of characteristics. So this upper trough, downstream of that upper trough, which is the entire portion of Western Algeria, that's going to be a region for substantial forcing of ascent by the basic quasi-geostrophic dynamics. And so there's not really any reason to believe it won't rain in these places to levels that they don't often see. And in fact, if we go to my newly revived QG Omega pages that Pete has helped me to revive, I can show you some evidence for that. Suddenly the colors look a little bit more subdued. So the brown is the borders of the country. So here's Algeria. I'm kind of outlining it with the cursor. And the Mediterranean coast, as I said, is not desert-like. The next level in the foothills of the Atlas Mountains is a little bit more desert-like. And then most of this part of the country, nobody lives there because it's the Sahara Desert. And what I'm showing you here is the 12-hour forecast from last night's GFS of the 700 millibar vertical motion. And that's blue if it's sinking and yellow if it's rising. And then these are the 500 to 900 millibar thickness contours every 45 meters, or every something like that. I think it's every 45 meters, maybe every 40 meters. Anyway, you can see there's the deep upper trough is the Cape Verde Islands. Here's the region of strong ascent. Most of that ascent is occurring in and around the region of the cyclone, which was at the Rock of Gibraltar. But there's a region of substantial ascent over Western Sahara, Morocco, and Western Algeria. And this is just this morning. Let me just go ahead a couple of times. I'll go to, let's see, 12 hours into the future. This is now going to be valid tonight, 7 p.m. Look at how the vertical motion has increased. It went from approximately 1 microbar per second to 3 over far Western Algeria. So this is a substantial upper trough at this latitude, and especially this longitude is unusual. And we'll keep on going. It gets worse for them. So this is 36 hours. Look at that. 1, 2, 3, 4, 5 decipascals per second is about 5 microbars per second in the heart of the western edge of the Sahara. So this is a region that is going to see rain, and it does not usually see rain. This is going to be quite an event for that part of the world. And I think that might be the peak. I'm not sure it is or not. Well, it certainly stays pretty strong in now the central Western Sahara Desert. That's unusual. And I think we'll probably hear about this as a news story for those who follow, news out of Africa. There's bound to be some stories about this because this will be an unusual event for them. And it's a function of an unusually deep upper trough for this time of year. So I'm watching out for locust swarms in northwest.
That's exactly where I was gonna go with that. So that news story might be several months from now, after they got some growth of vegetation with the new rainfall. There could be a huge increase in locust.
Yeah, and that's bad for places that manage water better and have serious thriving agriculture, because the locusts don't care.
Right.
They'll eat whatever they can, and they'll get blown off the continent eventually. But while they do, they'll land in places and do some real damage to some poor subsistence agriculture as it is. So that's all I have.
Okay. Thanks, John. And we'll actually start off. Yeah. Just a second. Pete, I have 2 logons. Could you give me permission on the second one, please?
All right, you should be good to go.
Okay, thanks. Okay, so you should see the, we're going to start off looking at a tropopause potential temperature map for the Northern Hemisphere. This is a map that shows the pressure in this case. So it's not potential temperature, it's actually pressure along the dynamical tropopause defined as the 2 potential vorticity unit surface. So this is a nice synopsis of all the key large-scale synoptic features over the Northern Hemisphere this morning. So this is a short-term forecast, 6-hour forecast from 6Z this morning. So it's valid at 12Z or 6 a.m. And what you can see, just to orient yourself again, here's Wisconsin in the lower central part of this diagram. I guess that's about 90 west. And then we have the color scheme. Here is the pressure. So these dark reds are very low pressure, so high altitudes. And where you see the colder or bluer temperatures, those indicate lower levels, higher pressures for the dynamical tropopause. So troughs will show up in the regions that are blue. Broadly speaking, the yellows and greens are going to be areas where we have ridges. And so the very deep trough that Professor Martin was talking about just off the west coast of Africa this morning shows up nicely along this dynamical tropopause map. So very low latitude excursion of what would be, if you looked at this on an isentropic surface or a pressure surface, high potential vorticity air at low latitudes is going to give us this characteristic, really impressive trough. But what drew my attention to this was, if you go back further to the west in the Atlantic, the central Atlantic, you can see a broad anticyclonic turning to the winds and very low values of pressure along the dynamical tropopause, indicating a strong upstream ridge. Not quite a blocking ridge, but a strong ridge in the central Atlantic. And I think that corresponded nicely to a positive height anomaly on the height anomaly maps that John was looking at earlier, as well as over eastern Canada and northeastern Canada, another area of really low values of pressure, so high dynamical tropopause, indicating a very strong ridge over Hudson Bay all the way to the west coast of Greenland this morning. And finally, you can see the trough that went through our area yesterday that was responsible for, and you can see the cyclone labeled at 983 hectopascals in the forecast over Lake Superior. This was the weather system that went by yesterday, gave us the snowfall. As you step forward in the forecast, I'll animate this. Hopefully this animation will start right off. I had it all loaded. You can see the evolution of the flow on this surface, and look at this area of very low pressure along the dynamical tropopause that gets sort of, I won't call it advected, but it moves all the way back toward parts of Western Canada. And then you can see the tropopause kind of circles back around over us during this time period. This is a very slowly evolving pattern. And because of the location of that ridge, we'll reload this again. This goes out through 384 hours, so about 2 weeks out. Because of the slow evolution of these features along this map, that's going to indicate that we're going to be into a weather regime that's going to hold pretty steady over us for most of the next week to 2 weeks. with cold air over us. So this is the beginning of that loop again. You can see, I'll stop it for just a moment, a very low dynamical tropopause over us, which is going to be associated with colder than normal temperatures over us. It'd be nice to have a map of anomalies of the dynamical tropopause in terms of its pressure, but this generally means that we're going to have low tropopause indicates in the mid to lower troposphere colder temperatures in that region, and so that's stuck over us for a while. We have this broad anticyclonic turning to the wind and flow to the north over Canada that's holding the cold air at a much lower latitude than you might typically see it. So this is the map that's valid for Tuesday of next week. And then if we just step through this again, you can see this broad anticyclonic ridge over Canada and the suppressed lowered tropopause height or higher tropopause pressure over us indicates a really cold pattern that's going to establish itself for the next several days. And so we're going to look at that, and then you can see this balls up into a very nice tight vortex by the time we get to 180 hours or so. We'll see what weather may be associated with that. But that gets really cold over us, and then it begins to relax a bit as the tropopause heights begin to increase. So we're entering a stage where it's going to be, we're expecting really low, cold weather over us for quite a while. Just to verify that, we're going to kind of scope down into the snow event that's coming up. But first of all, looking out for the next 6 to 10 days, this is the Climate Prediction Center's forecast for the next 6 to 10 days. And you can see this is pretty much a certainty. We're going to be below normal over much of the Midwest and the central part of the United States for the next 6 to 10 days. And that's associated with the pattern we just looked at on the dynamical tropopause. And you look at the 8 to 14 day temperatures, the same pattern. The pattern persists and actually shifts a little bit toward the east. So what this is suggesting, it's going to be cold, but what's really important to note from these maps is not that the intensity of the blue here is just the probability that it's going to be below normal. It's not that it's going to be super cold. So just keep that in mind. This could be just 2 degrees below normal, or it could be 20 degrees below normal. This doesn't really indicate how cold it could potentially get.
This is
normal.
This is a boon for energy traders, energy day traders. They know it's coming, and they can buy energy today and sell it 5 days from now at a premium. And I'm sure they're doing that.
Right. And so, I mean, that's good for regulating or sort of moderating the prices to some extent, but there are also folks that go in and speculate, and that's dangerous as well to the economy. So it kind of works both ways, I guess. In some ways it's nice, but it can be abused.
Yeah.
So something to watch for.
Just wanted to, there's a couple of things in the chat. Kaylin asks, would the ridge in the Atlantic and the trough over Algeria be associated with an anticyclonic wave break?
Yes, let's go back to that. This is the corresponding geopotential height. Just had that prepared. Let me go back to the beginning of the loop so you could see that. This will be roughly around this time. Okay. And you can see the ridge amplifying, but this trough in this case looks like it continues to be sort of progressed toward the east, kind of like was indicated by John's diagnostics one, and lifts to the north. So this is not quite a wave breaking event, but very often I think in the case that Peter Knippert and John Martin looked at a while back, in some cases that Greg Tripoli has also looked at, those associated with some anticyclonic wave breaking, but not in this case.
In our case, Michael, it was so interesting. Peter was alert to this, and I hadn't paid much attention to it. It's the upstream North American cyclones that initiate the wave break over the North Atlantic. And so if you have an energetic stream, if you have a lot of activity in the North Atlantic, some of it on the east coast of North America and some of it off Northwest Africa, they communicate with each other. And if the East Coast cyclones really build the ridge over Greenland and Iceland, that's when they can produce the anticyclonic wave breaks over Iberia and Northwest Africa.
Most definitely. So that's something, in this case it doesn't happen, but you would want to watch for things upstream over Eastern North America and the Western Atlantic that can play a big role in the downstream sort of propagation of wave energy toward the Eastern Atlantic basin, but not in this case. Any other comments or questions?
Andrew Quigley just says that some models are flirting with snow near the Gulf along the leading edge of the cold air outbreak this weekend. Yeah,
we're gonna see that. It's pretty impressive how cold it's going to get. And then so kind of zooming in a little bit, how cold is it going to get this weekend? A couple different perspectives. This is from our Weather Service page. I don't really like the color scheme they use because your eyes are kind of tuned into looking at really cold colors, purples and blues as being super cold, but it's actually the inverse on this particular map. But you can see for a number of cities in the forecast region of responsibility for Milwaukee, they have this period from roughly midnight Sunday through mid-morning Sunday as being the coldest period that's going to be experienced in terms of wind chills that they have here. And you can see the temperature forecast. While we were, John was talking, I also got a nice image relayed to me from Chris Smallcombe, who's a graduate of our program and is a warning coordination meteorologist out in Reno, Nevada. And this is the sort of box whiskers plot for the next several days for Wisconsin, or for Madison in particular. This is, since he's out on the West Coast in Reno, this is Pacific Standard Time. But it gives you a sense of the range of temperatures for the highs and lows over the next few days. And the models are this is from what's called the NBM, the National Blend of Models. They take all the models that have been run that are available for the period in time in question, and they post-process this data to create these box whisker plots, which show various percentiles for the temperature. And so you can see a few outliers going down to -23 for Saturday night, early Sunday morning, to -3 as a maximum maximum temperature possible for Sunday morning, with sort of mean around -9. But you can see this range of uncertainty in the forecasted lows, but pretty wide range. But that's pretty severe. Being in the single digits, maybe even double digits below zero when we get to Sunday morning. And we'll see how that all unfolds when we look at the forecast in just a moment. So I'll start off like I've traditionally done. I'm sort of getting re-warmed up after a semester sabbatical leave. I haven't done Weather Watch a lot, but I often like to look at John's favorite map, the meteorograms.
Yeah, the meteorograms. I love looking at them.
Meteorograms.
Oh,
and you can see the trend in temperature over the weekend is definitely downward. These are in degrees Celsius, by the way, not in degrees Fahrenheit. But you can see that downward trend in temperatures as well as the air drying out. But there is this curious brief period tomorrow afternoon. And we'll see that's as the cold air begins to really come in, where we have a shot at a little bit of light snow. And we'll see what that's all about, and at least one of the mechanisms responsible for it in a moment. Here's the time height section, again, for that same period, a 60-hour forecast, initialized at 12Z this morning, all the way out to 0Z on Monday. So that's 6 p.m. Sunday evening. Again, just to orient ourselves on these maps, the red contours are relative humidity, percent relative humidity, 70, 80, 90, 70 and 80% here, shown here. Green contour is the dynamical tropopause in this cross section or time height section. Yellow contours are potential temperature. And then we have the winds at various levels in the atmosphere, so you can see how their direction and speed changes with height. So you can get a sense of the thermal wind. And also from that, to the extent that the winds could be assumed to be nearly geostrophic, you can get some inferences about the temperature advection in various layers. And so we can see on this particular map sort of that drying out that we saw generally in terms of the relative humidity. You can see the formation during the day of what appears to be, in a very crude sense, a well-mixed layer, although it's maybe just due to the breezy conditions. It's not really, I don't think there's much convective overturn, dry convection occurring to mix these layers up. But mechanical mixing due to the breezy conditions this morning create that well-mixed layer. Overnight, the winds die off just a bit. Notice the wind's direction generally is from the west, and you can see the winds dying off close to the surface. Tomorrow afternoon, we do get another, layer in the lower troposphere where the potential temperature is nearly uniform. But you'll see as we go from mid-afternoon tomorrow through early evening, the winds shift very subtly from just west-northwest to more northerly, and they begin to pick up. And that's during that time period that the Weather Service was expecting that we're going to have some of the coldest temperatures, but also coldest wind chills as the winds begin to pick up again and the temperatures dive. A really interesting feature that shows up on this map is the dynamical tropopause becoming highly elevated as a ridge axis passes through our area. And you can see the pattern of descent as the ridge approaches, and then as the next upper trough, as we go through the ridge axis, a brief period of ascent in the mid-troposphere. And with any moisture, again, the relative humidities here are low. The moisture content of the air, is judged by the mixing ratios we'll see, is also low. But it's possible that we could squeeze out a little bit of precipitation in the mid-troposphere as this feature goes by in the upper troposphere. But there's also an important feature that's occurring in the lower troposphere that I want to focus on for the precipitation. So this is the NAM forecast for, I'll start off for today. We're looking at just temperatures and wind. And you can see we're clearly in it's probably neutral advection pattern. You can see the temperature gradient at the surface isn't particularly strong until you get into northern Illinois. And judging by the color scheme here, these are all kind of a uniform purple, maybe slightly deeper purples up in southeastern Minnesota. But the winds blowing in that direction are giving us some weak cold advection this morning. And obviously these temperatures at the surface are going to warm up just because of the daytime heating, but not super warm. I wouldn't call it super warm, but westerly winds. And then you can see creeping up in the map as we go 18 hours in the forecast. So by tomorrow evening, or by later on tonight, around midnight, you can see the cold advection beginning to show up, but it's also getting just colder toward northwest overnight. And as we continue in this, those colors get even more intensely cold. And you can also see, and this is kind of neat, if you look at the winds very carefully, you have to look that carefully, you can see a very nice, strong pattern of diffluence. The winds changing direction from northwesterly to more westerly over central Wisconsin, northwesterly to more northerly to even east-northeasterly. And there's a nice baroclinic zone that's beginning to form across this area, but there's certainly diffluence occurring along an axis of dilatation that's oriented northwest or northeast to southwest across the just toward northwest by tomorrow afternoon. And so that's a frontogenetical pattern as long as you have a temperature gradient associated with it. And this also, there's some evidence of it. It's weak. It's a little bit weaker when you get it into the upper troposphere or mid troposphere. This is tomorrow evening around 21Z, or so late tomorrow afternoon around 21Z. So what I did was, if you look at the forecasts at the surface in terms of precipitation during this same period, you can see along the leading edge of this, there is some precipitation. And one of the fundamental questions you might ask is why are we getting this precipitation? What's occurring? And so again, with the NAM, I took a cross section from about Belle Plains, Minnesota, all the way down to Flora, Illinois, kind of perpendicular to the thickness contours. And what's shown here is the frontogenesis, the 2D frontogenesis in this cross section. You're also seeing the vertical motion, omega, plotted here. And this light blue pattern is ascent that's occurring. And so along the leading edge of this region of frontogenesis, we are getting some ascent, which is expected. You can see a nice temperature structure associated with the front as well. And so it's sort of mid-level frontogenesis seems to be one of the key factors in producing this precipitation. If you looked at the height contour, you would see also some subtle evidence of maybe broad region of divergence downstream of an upper trough of a mid-level trough that's going through as well. But looks like frontogenesis is one of the key features that's producing this region of light precipitation.
Yeah, that's a really nice cross section, Michael, and well chosen and well described. That's exactly what happens sometimes with these passage of these. Really, they're almost not even waves. They're just regions of confluence or diffluence. And if they're in the right orientation to the isotherms, as you point out, you can get this interesting. This is going to be sort of like dust bunny snow, the kind where you can just step in a small pile of it and it just moves away from you.
It moves away, right? It just clears out.
40-to-1 ratio. It's really going to be quite a nice little snow event, and that's you've nailed it. That's what's doing it. And the air above the frontal zone is so poorly stratified, it doesn't have much resistance to ascent.
And that might be in part due to the fact that we had that ridge axis that was passing by us.
Yeah, that's right. Because of the way the thermal field has to look around that anomaly, right?
Right. So I think that might be one element that's that contributed to this. I think one of the concerns, if you are interested in snow, and I'm certainly, as John knows, I'm well aware that I just love snowfall. Yeah. Bring it on, and particularly 40-to-1 snowfall is great because it's just like dust. Yeah, and sweep it away. But I think one of the limiting factors for our area is going to be, you notice that most of the precipitation is to our south. I'll go back to the forecast. And we do get into this area of light precipitation, but it's, the heaviest is to our south. And I think part of that is due to the really low dew points that are going to be over us. I'll put the dew points and wind barbs at this time period. Actually, I should have dew point depression would be better. And I don't have that option on this. So I'll go back to just dew point by itself. See, dew point of 7. Air temperature of 11. I mean, I guess at some point, you know, it's still close to saturation, 7 and 11, but just saying 7-11, I get thirsty. I'm not sure why, but the fact is, low dew points, the low water content, even in the mid-troposphere, it's relatively dry, but it's, again, it's what's the relative humidity? Are you getting close to saturation to get precipitation? So dry air over us, but some light snow possible tomorrow. And if we look back, if we go forward into the forecast, go back to the GFS, and I'll just show you what the GFS has for precipitation. Again, it's a little bit more conservative with how far north the precipitation actually goes. So just a slight chance of precipitation as that feature passes by, but you'll see the biggest change in sensible weather will be the pickup in winds and the wind direction becoming more out of the north during the day, Saturday night into Sunday.
And sub 500 thicknesses. Look at that. That was 499 thickness and 498 there.
Right. But about a week ago, it was looking like we could even get into the 486 thickness range. And I'm not sneezing at this. This is certainly this is cold, but it's not the as cold as it could have been in the forecast.
Or might be next weekend.
Right. And so here's the light snow that's occurring over the upper Midwest, generally to our south during this period. I'm going to just enlarge the map or look at the larger scale. After this, you can see the baroclinicity, the main zone of sort of intense baroclinicity is to our south from Colorado through Tennessee and through North Carolina. And just to the north of that is where we're going to get these little pulses of snow, but it's going to be generally a dry period. And that was actually forecast pretty well by the CPC forecast is for us to be kind of below normal precipitation wise. As we get into early next week, again, early next week, we get a little bit of light snow that breaks out again, but it's just to our south with the main baroclinicity, and the cold air just continues staying in place with the severe cold air still locked up well into Canada. The 46 thicknesses are still up in there. I'll jump ahead. I don't want to step through every single time period, but again, it is a quiet week with that baroclinicity being suppressed to the south. But by the time we get to Friday of next week, you can see 480 thicknesses.
480.
Right, so sub 480 in international falls. And that cold air begins to move southward, but not rapidly. So fortunately, it doesn't think we get the deepest of the cold air. It stays there.
Oh,
but,
that's 480.
Okay, yeah, it's getting there. It's getting there.
Sub
Upper trough is rotating.
For Saturday next week. That's the coldest that's ever been here in terms of that variable for me. I've never had a 480, sub 480 thickness over me.
Right, and this is during the time period we saw in the tropopause maps, actually, that we saw that tropopause consolidating to a nice, more circular depression over us. And so the strengthening of that probably is going to indicate colder air. If you look at the air temperatures, I'll be honest, I didn't look quite this far ahead at the surface, but that's pretty cold. But again, we'll see what a week's forecast gives us because, no one needs that.
I didn't think I'd have a chance at minus 30 this year. In 2018, we had a chance, and I was disappointed we didn't get there. We were just talking about this on the phone the other day, Michael. We might have minus 30 next weekend. Wow.
And just to look at this, we look at the forecast trend, the model trend rather, for this particular model. These are all valid at the same time from the earliest forecast initialized on the 2nd at 18Z. And as we just step through this, and these are every 12 to every 6 hours as we go forward. This is all valid for the same time. There's a trend. It gets cold, it gets warmer. I don't know. The last couple of runs have been cold, but before that, they were kind of going back and forth on how severe that cold is going to be. But we are getting closer to the event, so maybe things will eventually lock on. So I would say I'm not yet ready to write the story of a minus 30 at the surface or anything close to that. But
what's the current 12Z wind chill forecast? As much as I hate wind chill, I want to know what it is for Saturday next week.
Okay, wind chill.
It should have been windy then too.
Brace yourselves. Oh, okay, this is loading up. We have to go back to the earlier forecast. Okay, around 6 degrees Fahrenheit, below zero. That's a pretty cold wind chill. From minus 34.
Look at that.
Oh gosh.
You can't go out in that weather. You just can't. At least you shouldn't.
Gotta
Oh
get
my
my steps in.
But I have
Yeah.
a question. I have a question. Hold
Yeah.
on.
You're not done yet, though. Hold on a second. We gotta see what
Hold
happens.
on. Hold on. This
Oh, my
forecast,
God.
the
Minus
GFS is showing on this map, look
Yeah.
at 48 hours. It's showing the same thing, more or less. What is that all about? It's been doing that for several days.
So yeah, this is the period. This is Sunday morning.
If you look at the actual temperature, look at the actual temperature for Sunday morning. It's been doing this consistently for a week.
Right. So that's the really cold, low temperature at 12 Z. Let me get out of
The
this.
official
mode.
forecast is not buying it. It hasn't been buying it for the last several days. What's going on?
Yeah. So again, looking back a week ago, we're looking at some pretty severe cold that didn't quite materialize. I don't know if it's
Well, it's
radiating.
not here
Some
yet.
people-
It was looking at severe cold for Sunday,
Yeah.
Sunday morning, and it's still looking for that.
Let's look at other models rather than sticking to one
Yeah,
model.
the other models don't agree.
Okay, so we'll look at the. I want to get the right compare models, latest runs for just 48 hours out. Okay, CFS is really low resolution, but that doesn't really matter. I think for a forecast like this, 1 degree on Sunday morning. Canadian is actually a bit colder, -15. Eastern WF, about -14. GPFS probably about the same. The ensemble, the GFS ensemble, -24.
Yeah,
So
even the
minus
ensemble.
27.
GFS has some serious problems with surface temperature, apparently.
Yeah. This
Yeah.
the HER, which is now 48 hours for the HER, the high resolution rapid refresh, that's -18 for Sunday morning. -6 or -7 for the NAM. 3-kilometer NAM, about the same. This is a Canadian product, and then the UK Met, -23. So
It's all over the map.
yeah, no
But
pun
what
intended.
I thought what was astounding is that they have been rock consistent on this -27 for
Right.
Sunday morning for almost a week.
Right. I was looking to see the chart that Chris Smallcombe had sent, which shows that the range in temperatures, but it was a pretty broad range that we were looking at for the low, anywhere from -20,
-23 to -4, I think it was.
-3, -4. Right. So a lot of uncertainty, but I guess the consensus forecast or the mean of those was about -7 or -9, somewhere in that range. So it'll be cold, but yeah. So these severe cold temperatures that are forecast by the models out to a week from now, take with a grain of salt, and probably take that grain of salt and spread it on the ice to melt it. It's going to be a little bit, there's some uncertainty there. I guess that's where I'll leave that statement.
I can't think of a single time, Greg, maybe you can back me up on this. I can't think of a single time in the 27 years that I've lived here where a forecast for cold was ever exceeded. It's almost always less than what's forecast. And I don't mean just the guidance. I mean the actual then human interpreted guidance. They both do the same thing. They both go for, it's going to be -25 and it gets down to -16.
Yeah, yeah.
It's always a 10-degree-ish error. And I wonder if I never realized that it might actually come from the guidance. And in an era where the proliferation of varying guidance is so extreme, it might get even more out of hand. That there's not just one channel you're looking at. You're looking at 8 different channels. And how do you decide which one you're going to go with?
Well, the stable boundary layer is always a problem. And one of the problems is that low-lying areas can be 30 degrees colder than a non-low-lying area. So in this kind of a situation, if the winds would calm out, which they're not, these are big wind chill situations.
Yeah.
But if these were without wind chill, you'd expect a variation of -30 to -10 sometimes on those very cold days.
Yeah.
But this is with wind. How can it be this wrong?
Yeah, I don't know. It's a really good point. And I'm putting my money on the coldest weekend of the year is next weekend. That seems certain to me, but I don't know if we'll get down to -30. And I don't see how. There's nothing upstream that's in the -15 range this afternoon. And even in the Southern Prairie provinces, it's not that cold. So I don't know how we're going to get to -24 by Sunday morning. I don't see that. But
Right. And with the big thing being, we're not going to really get the winds going calm. It's going to be a
Yeah,
breezy,
that's right.
cold advection
There's no
event.
cooling. There's no pooling and therefore cooling. So I don't get it. But I
Yeah, I
see
don't
that,
either.
you know, the amalgamation of that 850 millibar cold pool in small scale, it looks almost like late January 2018 by next weekend. And then we had a serious threat of -30, and that was way overdone. We got to like -22 or something. I don't think we got down that cold.
Yeah, that's right.
So anyway, it's you're right. I think it's very mysterious. I'm glad you pointed that out because I didn't know there was so much disparity amongst the models, even though with Chris's diagram.
Yeah, and so the last thing I wanted to point to, again, it looks like a relatively dry week coming up. This is the accumulated snowfall. Again, take everything with a huge grain of salt. This is a 384-hour forecast for the 10-to-1 ratio snowfall. And so for the next 2 weeks, you know, maybe about an inch or so of fresh snow over us. And if you go back and look at earlier runs, it's, you know, it's under 5 inches, I think, is expected during this time period. So we're entering a relatively dry period, and that's again consistent with the CPC outlook. If I can click on that for precipitation. This is the 6 to 10 day outlook, and this is the 8 to 14. 8 to 14 actually puts us closer to normal. So maybe a brief period. Again, the forecast for the month, there was no guidance on that, but for temperatures was for above normal. So maybe we're going to make up for lost ground if this forecast is to verify after 2 weeks. But it'll have to get super warm for us to, I think, get to average above normal.
I would think so too. You know, I was just thinking about something else too that is a factor, I guess, with relatively fresh snow. Sublimation's a factor. I guess that's going to cool the air a little bit right near the surface. And in the absence of it really becoming still for radiational cooling to go on, maybe sublimative cooling is about all you can hope for. It'll be really fun to keep track of the snow depth during this dry period that's exceptionally cold and presumably dry in terms of relative humidities, and just see how much of the snow gets eaten away by sublimation.
I don't, you know, really, you can't get much sublimate. The saturation mixing ratios down there at these temperatures are less than a fraction of a gram per kilogram. So the atmosphere has practically no capacity to hold any significant moisture at these temperatures.
Unless you're ventilating it with the wind. I mean, it might be the combination of, you know, sublimation and ventilation that can almost be a proxy for still air. Maybe. I wonder how much it would have to be to do that.
I think you'd have to have temperatures above 10 before you really got to start thinking about that.
Yeah, okay, that could be right.
Okay. So again, this is just to look at the precip forecast for the next 5.5 days or so. And again, a relatively dry period, but we're going to be on the edge. Remember, we had those little bits of snow that were going by to our south in the region of enhanced baroclinicity. And so we could, you know, latch onto one of those and get a little bit of snowfall. So we'll watch that in the forecast. But again, for the weekend, just getting colder slowly. And then we'll see the winds picking up tomorrow afternoon with maybe a very brief period of light snow. They'll leave a dusting or so, and then winds shifting to the north and getting cold. And the question that we've been just discussing the last few minutes has been, how cold will it get Sunday morning? Will it be just, you know, -5 to -10, or could it be far colder than that in the -15 to -20 range? Yeah. And that'll be something good to talk about next week and maybe discuss what happened during that period. But anyway, thank you very much, Pete, for setting things up. John, for a really wonderful weather discussion for the current weather, and everyone for participating. Have a great weekend.
Thanks.
Yeah, thanks, Pete. Thanks, Michael. See everybody next week.
You bet.
Take it easy.
Yeah, Ben Johnson in the comments was wondering if Minnesota could break their all-time cold temperature of -60 sometime this week.
I don't know. That would be embarrassing, right, Ben? Michael, you got that?
I got that. Yeah.
Yeah. Yeah, it might. I don't know. I mean,
that was really